Okay, so now we're going to look at domain and range in real world situations. So remember that domain is the set of x coordinates, which are also called the input, and the range is the set of y coordinates, which are also called the output. So we want to look at the input is going to affect the output, but the output doesn't necessarily affect the input. And if we think about that in a different way, if I think about rain and water levels in a river, and if you know anything about rain doesn't actually come from the area that you're in. It actually comes, rain clouds and stuff are created somewhere else and they come to your area. That's usually how rain works. So the water levels in a river aren't actually going to affect the ability to rain. But if it doesn't rain, it will affect the water levels. So we can kind of see that idea happening. So we're going to read this problem and we're going to see if we can identify the domain and the range of each. And so we have to bubble it in down here, and then we also have to identify the set of values. Now when you do this on Alex, it's going to be a drop-down menu. That's not very easy for me to do on a PowerPoint, so we'll just type it in, but I'll make sure that it looks exactly the same way it's going to look on Alex, with the exception of the drop-down. So a small publishing company is planning to publish a new book. Let C be the total cost of publishing the book in dollars. Let N be the number of copies the book produced for the first printing. The company can produce up to 100 copies of the book. Suppose that C equals 10N plus 700 gives C as a function of N during the first printing. That was a lot of information. My goodness. So with any word problem, and this is not just in math, anytime you're reading something, you want to kind of unpack it, and you want to read it more than once, because the first time you read that, whoof, that was a lot of information. I kind of got the idea. It's a printing company. So I want to go back and I want to read it again, kind of slow down, make sure I'm paying attention to the details this time. So a small publishing company is planning to publish a new book. So yay, I got that part right. I did get the idea. It's publishing a book. So let C be the total cost of publishing a book. All right, so it costs something to publish this book. Let N be the number of copies of the book that's being produced, right? So we don't know how many books are being produced. It could be 1, it could be 1,000,000. We don't know. For the first printing, the company can produce up to 100 copies of the book. Okay, so there's a limit. I have to do 0 to 100 books, right? Can't do less than 0. That would be weird to print negative books. Suppose that C equals 10N plus 700 gives C as the function of N during the first printing. So let's think about this equation. C, we've already been told that's the total cost. So I know this is cost equals 10N. Well, N I was told is the number of books produced. So why would I be multiplying 10 by the number of books? Well, maybe that's the cost per book, $10 per book, right? And then plus 700. Well, what would this 700 be? If I'm adding it, no matter what, that's not changing every time I'm going to add 700. Well, what that tells me is it's a starting cost. Since we're doing a total cost, I know these are all costs. So 700 must be the cost to just set up the printing or the publishing, right? So no matter what, it's $10 per book, and then I'm going to add 700 to that. So I can break this down by just understanding the ideas that I'm being presented with. So identify the correct description of the values in both the domain and the range function. Then for each, choose the most appropriate set of values. So this one, input is the amount that changes. So that can be a little misleading because technically the cost is also going to change. What I should say is input is the amount that we change, that we're deciding how many books are we printing. That's going to be our input. Am I printing 1 book? Am I printing 100 books? And then cost will change accordingly or because of the input. Output is the total. Okay, so total cost, that's going to be our output. So with this one, since I know that C is the total cost and number of books is the number of copies being produced, and we get to choose the number of copies, we know what our domain and our range are. The domain is going to be the number of copies produced. The range is going to be the total cost. Input, output. Okay? So set of values means the values it can be. So there are limits here. That's what we're trying to determine. So for domain, the number of copies that it can produce, I already talked about this, we can't do negative books. It has to be 0 or more, right? But then there's also a limit on the number up to they can produce. They told us they can't do more than 100 books, right? We can't produce less than 0 books, and the company has a top limit of 100 books. So that means that their set of values for the domain is anywhere from 0 to 100 books. So that's our set of values. Now for the range, we usually have to apply something from the domain. So if I publish 0 books, what's my cost going to be? Is it going to be 0? Ooh, tricky. It's not, because there's that plus 700. So if for some reason I set this whole thing up and I didn't produce any books, I'm still going to pay $700, because that's the setup fee, right? That's the starting cost. But then we also have $10 per book up to 100 books. So my top cost is if I were to do 100 books. So I want to do that 100 times the 10, because that'll tell me how much it costs to do the 100 books. And then I also have to add the 700 to that. So the set of values for the range is going to be 700. That's the minimum value, because I have to pay that $700 no matter what. And it's going to be up to $1,700 if I did 100 books, or if they did 100 books. So a little bit more involved when we're looking at a real world situation and we're breaking it down like this. So let's see. If we're looking at this one, keep in mind the set of values is a drop-down menu on alex.com. The wording or format can look a little different. So sometimes it'll look just like this, the way I did it. Or it can say the set of real numbers 0 to 100 can be 1, 2, 3 with, commas, 0, comma 1, 0, comma 2, and then ... 100. So that shows that it's going from 0 to 100. So it could look like this, where it goes 0 - 100. That means 0 to 100. Or it can look like this, where it is a list. Same thing with this 700 to 1700. It would go 700, but instead of going 701, 702, it would be per book. So it would be 700, 710, 720, 730, because every book is $10 more. So make sure you're paying attention to that list. I have seen them be a little tricky on that list before. Okay. But I think those are the only 2 options for right now as far as the way it's going to look. As we get, a little bit older and the math gets a little bit more complex, they do list them in different ways. But for right now, it's either going to look like I put it up here or as like a list like this. Okay, so now we're going to talk about cause and effect, because we're going to look at dependent and independent variables. So when we hear that in a word problem, it's going to ask us, what's the dependent variable? What's the independent variable? So dependent variable, that relies on something. It depends on it. So we have little babies here, right? They're dependent. Independent variable means it doesn't rely on something else. So we have some adults here who are independent. They're able to take care of themselves. So it's just kind of a silly little depiction of the two. So independent variables are the cause, and dependent variables are the effect. Okay? So the number of calories burned exercising, if we think about these situations. So what could be the cause of the number of calories burned exercising? Well, if we look over here to the effect, that depends on the number of minutes jogged or exercised or whatever it is you're doing, right? So it kind of just depends on the activity. They specifically picked jogged on this one. But it just depends on the number of minutes that you're exercising. Well, that will affect the number of calories burned. Number of pounds lost in a weight loss competition. Well, what could affect that? Let's see. So it depends on how many calories are eaten. Well, that could definitely have a big deal. If you are eating too much during a weight loss competition, maybe you won't be losing weight. That could also have to do with exercise too. There's a lot of different things that could, change the amount of pounds that you're able to lose during a weight loss competition. But we're keeping it simple. Number of movie tickets to buy. So what could cause that to change if we had people with us? So wouldn't that depend on the number of people that wanted tickets? If it's just me going to the movies, I'm probably only going to buy 1 ticket. But if it's me and my whole family going, I'm going to buy 5 or 6 tickets, depending on how many go. Because I have a whole house full of people. So that just depends on the number of people going for the number of tickets you're going to buy. So cause, number of people going. Effect, number of movie tickets you buy. All right, total cost of groceries. So what's going to affect our total cost of groceries? Well, hopefully we understand that it's going to be how many groceries we bought, right? If the fuller the cart is, probably the higher the cost is going to be for those groceries. Number of gallons used in your car. So that's going to depend on how far you've driven. The more you drive, the more gallons you use up. Cost of video games purchased. So that's going to depend on how many games you bought. That also might depend on the game you buy, but we'll ignore that little, change there. So we're just going to pretend like they're all the exact same amount, and it depends on how many games you buy. How fast you get somewhere. Well, that's going to be directly affected by how fast you're driving, right? So hopefully we're not speeding, but if we're, going the speed limit, we might get there faster than if we go below the speed limit, right? So that speed directly affects how fast we get somewhere. Amount of money saved weekly. Well, that could be affected by, how much we spend or how much we save. But by not spending as much per week, we can save more. Or just literally how much have we saved, we've put aside specifically for saving every week. The total cost of Redbox charges. Hopefully you know what Redbox is. I know that's kind of fallen by the wayside here, but Redbox is where you rent movies. So you actually go to the store and rent a movie. So the charges on Redbox are going to depend on how many games or videos you've rented and how long you've kept them too. Because you have to return them usually after a day. Or you get charged again. So these are just cause and effects. They're very simple ones. So we're going to take a look at a problem here. So in each story, there are two variables or quantities that are related. Each relationship has an independent variable and a dependent variable. The output is dependent on the input. Okay. So the output is the dependent variable and the input is the independent variable. So we're just going to read the situation and say which one depends on the other. Okay. So a graph in Atlantis shows how a city's average temperature varies in relation to its distance from the equator. Which is the dependent variable in the relationship? So what two values do we have? We have average temperature and we have distance from the equator. So these are our two variables. So to be dependent, the average temperature is going to depend. It varies in relation to its distance. So it's dependent on its distance away from the equator. So the average temperature is our dependent one. So the distance from the equator, if by chance I'm farther away from the equator, which should theoretically give me different temperatures, doesn't mean I have to have different temperatures. But the average temperature is dependent based on where we are from the equator. So one will change the other, but it doesn't necessarily mean that it's wrong if we're the other way around. So let's see. A function relates the input z to the output u equals 2z minus 6, which is the independent variable for the function. So this one's nice because they told us input and output. So as long as we remember input is the independent, output is the dependent, then we can very quickly identify independent is going to be our input, which is z. So we can just underline these two so we know already, and we're looking for independent, so it's going to be z. The amount of certain medication taken in the morning influences the amount of sleep that night. So which is the dependent variable? So again, which two values do we have? I have medication taken in the morning, and that influences the sleep. So those are my two. It's medication in the morning, sleep at night, right? Or the amount of sleep. So since the medication influences, it affects the sleep that night is the output, the medication taken in the morning is the input. Oops, I forgot to change those two. I'll have to change those. So with this one, since I want to know what the dependent variable is, I want to know which one depends on the other. Sleep is going to depend on the amount of medication taken in the morning, or whether or not the medication was taken in the morning. All right, so that's independent and dependent variables. I hope that helped, and I will see you on the next video.